Okay, fourth graders, today is Tuesday, December 10th, and we are doing Module 3, Lesson 32. Okay, we've been working really hard to divide numbers and working with division, and so today we're going to continue working with word problems and dividing numbers to solve word problems, but we're going to pay special attention today to the remainder. Because a lot of times when we do division equations, we just write R3 or remainder 3, right? But when it's in the context of a real life situation, a word problem, the remainder actually has a different meaning sometimes, right? And so we're going to take a look at the context of the problem and understanding what the words mean to understand what to do with the remainder. Okay, Herta, are you ready to join us? Okay, quickly. For your problem of the day, it asks us to take a look at this tape diagram and then create a word problem and then solve the word problem. Okay, so let's first take a look. What are some facts we know about this tape diagram? What are some facts? Zara?
We know that the whole is 4,194.
We know that the whole is 4,194. What else do we know about this tape diagram? What are some other facts? Swarnima? There's 3 in one group, which means we're going to be dividing by 3, right? So what kind of problem is this? Grouping or sharing? Everyone? Grouping. We know exactly how many are in each group, but we don't know how many groups there are. That's what we're trying to figure out. Okay? So at your table groups, I want you to share with each other. You're going to start with the person sitting at the end, so Anshul, Sachi, and Islet. You're going to go around clockwise. You're going to read your word problem out to each other, and then you're going to check your answer at the very end. Go. So today, remember, we are going to be doing division problems, but we need to think about what the remainder means. Okay, so let's start off with this one. It says there are 7 days in 1 week. We know that. The question's asking how many weeks are there in 259 days. So let's draw a really quick tape diagram. How many days are we working with altogether? 259. And I want to group them into weeks. So if I make one group, my first group is 1 week. How many days is that? 7. If I have 2 weeks, how many days is my second week? 7, etc., right? And we're trying to figure out how many groups of 7 there are. So let me ask you a question. Is this grouping or division? Grouping or sharing? Grouping. Do we know how many is being shared into each group? How many days are in each group? Each group is called 1 week, right? So how many days? 7. So we're trying to find out how many. So this is a grouping division problem. What division problem should we do then? What's the equation? 259 divided by 7. Let's go ahead and do that. Can I do 200s divided by 7? No, so I have to regroup it. 25 what's? 10. So what's 25 divided by 7? What's the biggest whole number I can come up with? Avani?
21.
21, which is?
3.
3. So I'm going to put 3 tens in the quotient. As Avani told us, 3 times 7 is 21, which means I have 4 tens left over. If I bring down the 9, how many 1s do I have? 49. What's 49 divided by 7, everyone? 7. So 7 times 7 is 49, and the remainder is 0. Do I have a remainder in this case? No, so there's no remainder to worry about. Let's go back and read the question. I think my answer is 37, but I need to put a label to it. Zara, what's the question asking?
The question is asking how many weeks are in 200.
Good. How many weeks? So the answer is 37 weeks. This is why it's always important to underline what the question's asking, because that will help you determine what your label needs to be. Very nice. Again, a remainder was 0 in this case, so there wasn't much to interpret. Let's move on to a different example to see if there's more to interpret there. This question says, everyone is given the same number of colored pencils in art class. If there are 249 colored pencils and 8 students, how many pencils does each student receive? Go ahead and write down what the question's asking. How many pencils does each student receive? The important information is that there are 249 colored pencils and there are 8 students altogether. See if you can challenge yourself to draw a tape diagram using the important information and what the question is asking. For our tape diagram, we know that all together we have how many colored pencils? 249 pencils. How many people are sharing them? 8. So I have to divide it into 8 equal-sized groups. And we want to know how many are in one group, because each of those is one student. So is this a sharing problem or grouping problem? Sharing. Very good. Okay, so we have to do 249 divided by 8. What's going to be our first real division problem? 2 divided by 8 and 24 divided by 8. 24 divided by 8. But it's 24?
Tens.
Good. If I have 24 tens and I divide it by 8, how many tens do I have altogether? 3. So I'm going to put a 3 in the tens place. 3 times 28, 3 times 8 is 24, which means I have 0 tens left over. Am I done? No, because I still have the ones. I have 9 divided by 8. What's 9 divided by 8? 1. How many ones did I use up? 8. So what's my remainder?
1.
So my answer is 31, remainder 1. Let's think about that remainder. What's the question asking us? How many colored pencils each person can get? If there's 1 pencil left over, do we break the pencil up and give everyone a little bit of it? So how many colored pencils can each person get? Everyone? 31 what? Pencils. So what happened to the remainder? We just ignore it because it's just an extra. You can see that in the context of this problem, the remainder means that we just ignore it because if there's 1 extra pencil, there's 1 extra pencil. Who cares? We don't care about that pencil. Does that make sense? So does this mean that whenever we solve word problems and there's a remainder, we ignore it? No. Sometimes we need to think about the remainder, but in this case, we don't add the remainder into the answer. Okay, so this question is asking us how many nets can he make? That's basically what the question's asking. The important information is we know that he has 155 meters of the nets altogether, and each court or each net requires 9 meters. So if we were drawing a tape diagram, we could show that altogether we have 155 meters of netting. And if I want to make 1 net, I need 9 meters. If I make another net, I need 9 meters. If I make another net, I need 9 meters, so on and so forth. And I want to find out how many there are altogether. So is this grouping or sharing? Everyone? Grouping. Good, G for grouping. So what division equation do we need to actually do? Haruto?
155 divided by 9.
Very good, 155 divided by 9. If I do that, I can't do 100 divided by 9, so I'm going to regroup it to become 15 tens. 15 tens divided by 9 is what, Anushka?
It's 9 times, it's 1.
110, very good. And then Mom would multiply. 1 times 9 is 9. When sister subtracts 15 minus 9, how many tens are left? Kaship?
6 tens.
6 tens. We're going to regroup that 6 tens to become 60 ones. If I bring down the 5, I have 65 ones. What's 65 divided by 9? Garrett?
7.
7, very good. Because 7 times 9 is 63. And I have 2 meters left. So what does that mean? That means that Mr. Hughes can make 17 full nets. And at the end of making 17 full nets, what will he have left over? 2 meters of netting. Can he do anything with those 2 meters? No. Can he make a full net? No. Do volleyball players want like a partial net? No. So the question is asking how many nets can he make? How many nets can he make? 17 nets. What happened to the remainder? We just ignored it. How come? Why did we ignore the remainder in this case? Talk to your table groups. In this case, we saw that the remainder was 2, which means that at the end of making 17 nets, he would have 2 meters left over. Well, he can't do anything with those 2 meters because it takes 9 meters to make a net. So those 2 meters, they're just extra. They're on the side. So the question's asking how many nets can he make? The answer is 17 nets.